name is Christian Hodges, and today Alex, Eric, and I will be presenting our project of predicting MLB outcomes with machine learning and historical modeling. Today we'll give an in-depth look at our project. We'll start by introducing our topic and why we chose the dataset that we did, followed up by going over the data source and strategies we used in order to get it ready for analysis. We will discuss multiple modeling techniques and methods used to generate our final predictions. Then we'll touch on why we chose the methods we did and how they each played a part in our final model. Once we've gone over how our models were developed and why, we'll compare our results to another game prediction site and random chance to show how our initial model stands. So before we dive into our topic, I want to give some background on the project we chose and why. So with sports betting becoming legal across the U.S. and all three of us being huge fans, we believe that there are increasing opportunities to provide services to assist better selections, including our own. We chose baseball as it is currently in season, but we believe these concepts and strategies can translate to numerous other sports, as well as product launches, movie releases, and even political elections. Our goal is to create a unique solution to betting using data-driven decisions. Today, our presentation includes the first steps in a model we look to continue to develop in order to provide a confident and accurate service in the future. Like I said before, with sports betting becoming legal, there is an increase in opportunity to make money off of betting and a necessity for deeper insight into placing bets. Our project is based around using machine learning techniques to analyze historical baseball data and make accurate predictions. Our dataset was all pulled using a Python library that scrapes baseball reference. The goal of this project is to make data-driven decisions when making bets on MLB games. Unlike other prediction sites, our goal is to surround our predictions with more data, as well as provide more insight to those who might use our results, including confidence intervals and things like that. This includes previous betting results and other sites' historical predictions, which we'll get into shortly. As for the dataset used for this project, it was primarily pulled from a PyBaseball library in Python that connected straight to the Baseball Reference API. We pulled data between the years of 2000 and 2020. This consisted of team batting and pitching stats, individual batting and pitching stats, individual player keys, and the full schedule and record for each year. Our dataset totaled over 49,000 data points, with each team's full home schedule present, as well as 64 features and one label that we used in our modeling. Once our data was pulled, it was uploaded into a MySQL database where each dataset was mapped together using primary and foreign keys based on team IDs. Before any normalization or modeling began, we removed all columns with future values that would not be present at the beginning of a season. This included things like the win and loss record, innings pitched, games started, games completed, etc., since our model would not be able to compare a team with a full 162 game schedule to one who had not even played yet. Due to some teams having an inconsistent number of innings and games played, before conducting min-max normalization on the data, we converted all applicable stats to a per inning. Once this was taken care of, we were able to min-max normalize all of our data to begin the modeling process. We also collected NumberFire data, which is the prediction site that we will be comparing our results to later on, as well as betting information starting in 2010 season to see how our model would have fared over the last 10 years. With collecting data, there were a lot of bugs in the code that we had to work around in order to get our data accurately representing the past 20 years of baseball, and some fixes that we provided along the way, which we'll get into now.
Hey, it's Eric, and I'm going to go over the learning techniques we used as well as the techniques we used to evaluate our results But first I want to talk about some of the trials and tribulations we had with the data. Sports data is pretty messy stuff. Different sources use different abbreviations to refer to the same teams. There are instances of multiple players having the same name, and the historic results data we pulled had each game split across 2 rows of data, one from the home team's perspective and one from the away team's perspective. Correcting for all these things and many more wasn't particularly challenging, but it did take a lot of time and effort. Now let's move on to a more interesting part of the project, how we built and evaluated our models. Our ultimate goal is to predict percentage chance a team has to win a game, not to predict the winner. And this is an important distinction because what we're looking for is good bets, not the winner or loser. Return on investment of our bets is the ultimate measure of success, so let me quickly explain that since it frames our evaluation techniques. When you bet on who will win a baseball game, there are odds involved. These odds imply how often the teams you're betting on has to win in order for you to break even or make money over the long run. If we can predict the chances of victory, and those chances are greater than the break-even percentage, we have a good bet if our model is accurately predicting that percentage. So in the example below, if we predict that the home team has a 60% chance of winning the game, betting on the home team is a losing proposition since we have to win 65.5% of the time for us to even break even. Whereas betting on the team we don't think will win is a good bet since we only have to win 38.5% of the time for that bet to break even, and we think it's going to win 40% of the time, so we're going to be making money in the long run. So how do we do this? How did we predict the chances a team has to win the game rather than who's going to win or lose? We used many methods, including, confusingly, 2 classifiers. Why would we do this? There are a few reasons, actually. For one, we wanted to see how well a classifier could predict outcomes, which for both the neural net classifier and the SVM was about 58%. This reinforces our inherent belief that baseball is a high variance game and that the edges are very small in it. Further, we used k-folds on the MLP classifier to validate the data set. That is, when we saw everything was consistent across the folds, it gave us some confidence that our data was suited to the task, and also to a lesser extent that we didn't screw anything up in organizing the data and gathering it. We also ran a sensitivity analysis on the final version of the classifier to identify what it thought the most important features were to winning a game, and I'll tell you how we use those in a little bit. This is just a snapshot of the k-folds cross-validation results that I mentioned above. So how did we actually estimate percentage chance to win games? We used 2 main methods here. One was an MLP regressor, and the other was a more novel method that looked for historical surrogates and then treated those effectively as a set of weighted ensemble models. The MLP regressor is pretty straightforward. You use a regressor, you get a number between 0 and 1, which is treated, in our case, as the percentage chance we think the team will win. For the other method we used, we looked for historical surrogates to the game we're predicting, and then treated those surrogates as a weighted ensemble of models. There's a lot to unpack there. Let me first say why we did this, and then I'll tell you how we did. First of all, this is a pretty new technique, at least as far as we know, and we wanted to examine this and get our hands dirty with it. We know of a couple of sites who do the exact same thing we're doing, who use this method in building their predictions, but we don't know exactly how they choose their historic games that they're using as surrogates, and we also don't know how they incorporate those surrogates into their final prediction. It's rather opaque. So we took our stab at it, and this is what we did. We took all the historic teams from 2000 to 2020 and characterized each by a set of features. And by that I mean each team in each year was a distinct entry. So the Phillies in 2012 are distinct from the Phillies in 2014. We then took these teams and we used k-nearest neighbors to group them together. And here's where we used the data from the sensitivity analysis I mentioned before. We did 2 things. We treated all the features equally, and then we also had another case where we weighted them based on what the classifier above thought was more important. Then we took current matchups with up-to-date features for the home team and away team. And we looked historically for matchups where home teams from the neighborhood of the home team were playing away teams from the neighborhood of the away team. We gathered these up, and then for the matchups themselves, we put how close the historic matchup was to ours based on the distance function we used to build the neighborhoods in the first place. Then the ones that were closer got more weight. And then we used those weighted win losses calculate our prediction for how many times each team would win the game. So you can think of it as each of the historic games as a separate model for who's going to win this game, and they're weighted based on how close they are to the game that we're trying to predict. So now we have to talk about how we evaluate these models, and we did it in two ways. The first way I'm going to talk about is using Breyer score. Now what Breyer score is the difference between your prediction and the actual result of a game. So if we have a team who we say is 60% to win, and they do win, the Breyer score is 0.16, 1 minus 0.6 squared, and if they lose, it's 0.36. So if you're comparing one model against another model, and you have two sets of predictions for the same games, and the outputs for those games, if you go through and calculate the Breyer score for each of those models, or the average Breyer score, which is a little bit easier to work with, then whichever model gives you the lower number wins. That's a great way of measuring one model against another head to head. But if you're trying to just evaluate how accurate a given model is, you have to do something slightly different. Well, you'd look at if your prediction is exactly perfect, that when you say a team is 60% to win, then you can calculate what their expected Breyer score would be. That method is how we tuned our regressor. The other method we used for evaluating the models was how they did from an ROI perspective. In this case, with the historic surrogate model, we took for that very small sample set what bets we thought were good. We placed those theoretical bets and saw how they did, and compared it to what bets Numberphire thought were good against their theoretical bet. For the regressor, which was trained with data from 2010 to 2020, since that was the period we could harvest historic betting odds from, we tested exclusively against historic results. Here, the code would look for good bets to see how they performed. We further bin the results into 1% bins. That is, where a predicted win percentage was 0 to 1% higher than the break-even percentage, 1 to 2% higher than the break-even percentage, etc. We did this for both the training and the testing set of data, though the testing set of data obviously is the one that carries weight in this analysis. So the results we got from this were pretty interesting, and I'm going to throw it over to Alex to talk about those.
So now we're going to do just a quick overview of how sportsbook lines are created and generally how they're going to get to you. And so there's mainly two types of sports books. One which most people will not experience in their daily life, which are the line setters. And it's their goal to get the initial lines so that the rest of the sports books can then take those lines and put it in their own sports books to offer to the majority of the public. And so how the line setters work is they'll open up the game with some line that may not even be close to what is accurate or that is clearly biased in one direction, but they'll set it at a very low limit, say like $100, and all these people will immediately start betting one way, which then the sportsbook knows to adjust the line to compensate for that. And then they'll raise the limit, more people will get in there, they'll raise the limit, more people get in there until they kind of reach equilibrium. And that happens very quickly over the course of just a couple hours, right when the lines are opened. And then those lines will then be passed on to most of the public sports books that people use, such as FanDuel, DraftKings, all the mobile sports books, all the ones that you'll see, and that the different states are opening up access to right now. And so as they get passed forward into the public sports books, the hold typically gets lower because they're more confident in the results, so they don't have to hold as much money from the public. And what I mean by hold is that for every bet they set up, if you bet both ways, the casino is always going to win money. They're always going to take money off of the top from the bets. So they make sure that if the bets are bet equally each way, that means they always are going to make money and they're not going to lose. And so as you get towards the end of the line, these holds are going to be very small because they're very confident in these lines. And so after that, the general public may adjust the line a bit by betting one side, but typically they don't take too much of that into consideration. Or an injury may come out that may shift the line, but they will move slightly after the public gets a hold of them, and that's what I'll be talking about with closing and opening lines. When they get opened to the public, that's the opening line, and then they'll close when the game starts, which is typically slightly different and slightly less hold because they are more confident in his lines if they got more information from how the public's going to bet. And so now to apply it to our results. Next, we have the results for the neural network. And so this one we trained and tested on all of the data from 2010 through 2020. And we ran it for both opening lines and closing lines. I will only show you the results for the opening lines, but we didn't run it for the closing lines too. But we weren't expecting that to be as good as the lines adjusted and became less room to really make some money off of it. And so we took 75% data, sent that into the training, 25% for the testing. Overall, testing data received a REAR score about 2.41, which is good because that's above the 0.25, just being 50% on every game and getting half of them correct. And so here's the chart of mainly our final results for these opening lines. And so all bets were set up to win $100. So if it was a plus 200 line, you're going to bet 50 because it's 2 to 1. If it's a minus 200 line, you're going to bet 200 because it's 1 to 2. Everything in between, everything above and around, to just get everything to make $100 if you win that bet. And so the first thing to look at here is just look at the total at the bottom. You can see we made $4.51 per bet, which is good, and that equates to 4.38% return on the amount of money we risked. So of the money we risked, we got 4.38% back, which is good because that means we did really well and we picked a lot of good bets. But the second most important thing to see is the right side of the chart. And so what this range in the charts represent is the EV, so the expected value from our bet. So from our neural network, we came up with a percentage chance for a team to win. And using that percentage chance, you can look at the lines and figure out, okay, if I bet the line that's more favorable, how much money am I expected to make? And so obviously as EV gets higher, you're more confident in that thing and you're expecting to make more and more money from that bet. And so that's good because with our results, you see that as we get above 0.1 all the way to 0.2, we are increasing in the return in each one of those categories and we're getting better and better. And the higher EV bets are doing well and the lower EV bets are still doing well, but the higher EV bets are doing better than the lower, which means that our EV calculation is confident that it's working. And you can see that the return on bet for those high EV bets was about $9.74, whereas only $3.80 for the low EV bets. But overall, both positive, both good, and that's what we were looking for. And so next, we'll just go over the K and N. And so here I'm going to compare it to NumberFire. And the reason why I'm doing that is NumberFire is a service that provides you with sports analytic data, whether it's fantasy lineups or game predictions, and they do this in a similar way to we try to do it with the K&N, where I'm not sure of their exact methodology because obviously they don't reveal that, but they basically pick the most historically similar teams, and then from that you can get the most historically similar games, and from those you can figure out what percent the historical similar team to one team won, and that will give you the percent chance that they would expect it to win this game. And now we don't know what weights they use, what data points they're using, all that stuff. So we try to recreate that with ours. And so we took data from 2000 to 2020, and that's all the teams' stats from there. And those are the ones that we're going to compare our current team stats to. And so we z-score normalized all those stats, z-score normalized the current team stats, and then we just did a K&N with a distance matrix, Euclidean distance, to figure out how close each team was. We picked the top 100 teams from that list. Sorry, we picked the top 100 games between similar teams with the lowest distance to the current game, and we used those to figure out what percent chance we thought each team was going to have. And so here you can see that our raw accuracy was 63%, and theirs was about 63% as well. So we're doing pretty well with respect to that. Our Briere score was very similar. Ours was 0.236. Theirs was a little bit better at 0.229. So they weren't taking as many risks with, some of the bets that they had. So, they didn't have as many 80% confident games as we did, or games that were very high percent chance that they were going to win that we thought. And the most important thing though to see is that our average money made per bet was 71 cents as opposed to theirs, which was losing 63 cents. And so we made about 6% on our total risk, and they lost 9% on theirs. And so it means at least over this small range, we can see that we did better than them. Now, whether that holds over the whole season, that's still to be determined. But for the results that we tracked, we saw that they did do well. The average hold on the bets was just around 4%, just to show how much the sports folks were taking off the top. So a lot of this is tough to like grasp when you're talking about 32 teams or 30 teams per season, 20 seasons, and you're comparing them all. And there's no really good way to show those kind of charts. So what we did was we took all of the historical teams from 2000 to 2020, and we rated them all against each other and got a giant distance matrix that showed which teams were closest to each other by raw distances, and then from there, we can throw that into multi-dimensional scaling to bring it down to 2 dimensions, so we can try to show similar teams where they're at, and so you can compare. You can see a team in its range, and you can see where it is with respect to other teams like it. So here in this chart, we plotted it. You can see the green stars are going to be the World Series champions, and the black squares are the worst teams in the league. The red X being the Astros in 2017, as they cheated. And so here you can see the World Series champs are generally grouped up, although there is a little bit of spread, most likely because teams tend to get hot and win the World Series, or teams win the World Series on different aspects of their team. Some of them have really good pitching, and they'll send out 3 good pitchers in a series, and it's tough to beat each one of those, and so it's a low-scoring series. Or some teams will just have insane run potential and will just be scoring a ton of runs, and they don't really need that pitching. So that's where the variance and that's going to be at. But the most important thing, as you can see, is all the black dots are a little bit more tighter grouped up because teams that are bad typically don't have good stats. So you can see that our K&N method is recognizing that and grouping them together and saying these teams are all similar, these teams are all close because they're bad. And the World Series champions, these teams are all similar, they're all close because they're good. The only exception being one green star that's in there. It's Kansas City in 2015. I'm not sure why they're that low, but maybe they got really hot end of the end of the season, just won closely contested games. But also, I mean, we're reducing 21 dimensions down to 2, so there's going to be some tough things to plot too when we're looking at all these distances, trying to smush them down into 2 dimensions. So it could just be a victim of that, or the or the evenly weighted stats, and not doing that. So lastly, I mean, there's a million ways we can obviously improve. I mean, there's no way this method is perfect. It has encouraging signs, but just off the starters, one of the most important things we could probably do going forward is adding starting pitchers to the data, because there are a lot of teams that have one good starting pitcher and a bunch of average starting pitchers, and every time that good starting pitcher pitches, obviously they're going to have a much higher chance to win than any other game with any other pitcher, because that pitcher is going to be letting up less runs. So even if they don't score as many runs, that starting pitcher himself will let up less runs. And so adding that in will probably give us more accuracy and more confidence on a lot of our bets, as well as just any other player on the team. For example, the Padres were missing Fernando Tatis for most of the season. He just came back, but I mean that's a lot of runs that he accounts for that team's going to be missing. And so that would definitely be nice to incorporate in it when looking at a daily basis about who is actually going to play that game. And then another thing would be we didn't weight our K&N at all. We didn't really have the time to do that. We needed a little bit more time to get that done. And so we could go back and we can train it on that 2000, 2020 data, and take a training set out of there and take a testing set out of there and figure out what weights would be best for each of the stats in the K&N. And that can possibly give us a lot better accuracy at figuring out who's going to beat who and and what the results of the games are going to be. Another thing would just be using ensemble methods. They're basically useful everywhere. Always good to increase accuracy with that. And another one would be incorporating recent team performance, because teams go through up and downs over a season, especially a baseball team. Confidence is a huge thing in baseball because it's such an individual game where every time you step up to the plate, it's basically 1v1. It's you versus the pitcher. And so if someone's confident, that mentality is going to help them a lot in the batter's box, as opposed to when someone's not confident. So if a team's confident overall, most people are confident, they're going to be doing better all over the field. And so that would be nice to incorporate into the thing, even though it doesn't necessarily have something that's quantifiable. But there might be some way we can add in recent team performance in order to better reflect our data. So and obviously there's multiple things that we can add on to that, but those are some of the main points that I wanted to get from Improve. So that's the whole thing. Hope you got something from it. Hope you enjoyed it, and thanks for listening.